If you were granted a power that could tear atoms apart from thousands of miles away, vaporize steel in an instant, and erase every biological imprint inside a living organism, would you believe it? Yet somewhere deep in the universe, there truly exists such an object. Its horror goes far beyond anything humans can imagine. It is called a magnetar. On March 5, 1979, human probes suddenly detected an abnormal gamma-ray burst. That torrent of energy almost instantly broke through the solar system's defenses, causing multiple satellites to overload. Scientists were terrified to discover that this single burst carried as much energy as the sun would release in 100,000 years, and it lasted only 0.2 seconds. Even more bizarre, the source was 50,000 light-years away from Earth. At that moment, astronomers realized there is something in this universe beyond human understanding. Later, we gave it a name, magnetar, a type of neutron star with the strongest magnetic fields in the universe. Imagine a star with a mass 8 to 25 times that of the sun. When it runs out of fuel, what happens? That's right, a supernova. In that world-ending explosion, the star's core collapses in less than a second. Protons and electrons are crushed and fused together into neutrons. A stellar core thousands of kilometers wide is compressed into a sphere only 20 kilometers across, with a density of 1 billion tons per cubic centimeter. But that isn't the scariest part. Under extreme conditions, about 1 in every 10 neutron stars becomes a magnetar. Its magnetic field can reach 10 Gauss, 1,000,000 billion times stronger than Earth's. What does this number mean? It means at a distance of 1,000 kilometers, its magnetic field could completely rewrite your atomic structure. The iron atoms in your blood would be stretched into needle shapes. Your DNA's double helix would be torn apart as if an invisible hand ripped it open. Your neural signals would instantly collapse before you even have time to feel pain. Even more unsettling, magnetars aren't always quiet. They experience what astronomers call starquakes. Imagine a world with unimaginable density, and its surface suddenly undergoes violent crustal movement. The T-crust, only 1 kilometer thick but 1 billion times harder than steel, can crack under magnetic stress. Yet that crack might be less than a millimeter wide, and the energy it releases could illuminate an entire galaxy. On December 27, 2004, magnetar SG R 1806-20, 50,000 light-years away, experienced such a starquake. In just 0.2 seconds, its brightness exceeded the combined output of every star in the Milky Way. If it had been only 10 light-years away, Earth's ozone layer would have been stripped instantly. All life would be exposed to lethal cosmic radiation. Fortunately, all known magnetars are far enough away. But astronomers estimate there may be 30 million neutron stars in our galaxy, and at least several thousand are magnetars. Yet we've only discovered about 30 of them. Their magnetic lives are short, only around 10,000 years. On cosmic scales, that's just a blink. But in that brief 10,000 years, they spin dozens of times every second, releasing radiation capable of penetrating space for several light-years. As they lose energy, they cool down, their magnetic fields weaken, and eventually they become ordinary neutron stars, a cosmic corpse rotating eternally in the dark. Yet while they are alive, any life within thousands of light-years must tremble because of their existence. More disturbing still, some magnetars can suddenly awaken. After years of silence, they can erupt without any warning. In 2020, a magnetar thought to be already dead suddenly emitted a fast radio burst. This was the first time humans detected this phenomenon inside the Milky Way. And what does that mean? It means those magnetars we think have already died may wake up again at any moment.